Welcome to networknuts YouTube channel. I am Alok Shrivastava and another very interesting topic on Kubernetes. So the prerequisite is you should be comfortable with Kubernetes. So let's take a problem here and then we will discuss the solution. So guys, the problem is, let's check the problem first. So we have a cluster. Let's suppose this is the cluster here and some nodes are in the cluster. Obviously the machines will have finite amount of compute. Let's suppose this is node A, node B, node C, right? Node A, node B and node C. So let's say the memory, this node A has got 2 GB RAM and has 2 core of CPU, and all the machines have like similar hardware configurations or might be different. So let's take it 2 GB on all the machines, but you might have a setup with all the machines have different hardware configurations. So let's make it 4 GB of memory and this has got a 2 core of CPUs or 3 core of CPUs. Now we have an application here. We intend to run 2 applications. So one application is, you can say, it's not that critical. So let's call it, say, application normal. App normal. It's a normal application. We intend to run this with a blue color, whatever the color is, blue color. So, and let's suppose we are running this application and I need 3 copies. So I'm just trying to give you a simple calculations also. Say we wanted to run this application on node A, we can easily use node selector. So let's say we intend to run this application on node A. As this machine, node A has got a certain specific hardware. Let's suppose it has got a SSD hard disk or a GPU. Let's say GPU. It has got a GPU here. These machines don't have the GPUs. So we can use the labels and the selectors to mark it. Now, say we want to run 3 copies of this application. So we will be using a deployment and 3 pods I intend to create. And okay, if it is a 2 GB, so let's say 6 3s are 18. So every pod is asking for, say, 600 MB of RAM. 600 MB of RAM. This I can configure it in the deployment section. So total comes out to be 1.8 GB of RAM. And because I have used the node selector, so the whole application will be going onto this machine, right? I have used node selector, used node selector. So this application is successfully running here. 3 pods are running. They have used around 1.8 GB of RAM on the node A. Cool, all is running proper as planned. Now I or the company wanted to run another application. Now this is going to be say a high priority application. So let me change the color here. So let's put it in the green color. So we have got another application now. So this is another app. I call it app priority. This is a priority pod application. This application is also running 3 pods and it is also running in the same quality of service. So this is also asking for 600 MB RAM each. 600 MB here, 600 MB here, and 600 MB here, right? And this also intend to run on node A because of the GPU thing. Both are the same application. We can also think of it like, say green one is running in the prod environment. Let's take it like this. So the green one is running in the production environment, and the blue one is running in the test environment. We can say it like this. This is the test environment. So earlier the test and application is running on node A, and the node A has got 2 GB RAM. And it has already consumed, the application has already consumed 1.8 GB when it is running on node A. Now we don't have any more compute available on node A. Now the company wants to run another application, the priority application. It might be the same application but in a different environment. So what will happen now? If again I am using node selector and I intend to run this on this machine, what will happen? You got it right. We don't have resources here. Resources are already consumed by the test application, the blue application. So these pods will be in the pending state, right? They will be in the pending state because they are already running. That is the problem. Now, in my case, the green application is a priority application. What do you really think you need? What I need is, if the priority application is coming onto the node and the node has got no free resources, it should take out the other application. So what I want is that the scheduler should take these applications and evict it from the node, right? Evict them. Evict. So that the high priority application should not be in the pending mode and they should be deployed. This is what I want. Isn't it? This is what you also want. So how can I do it? Because these applications, the normal application was already running. How can I do that? That's the problem. So this is the problem you will face on a daily basis. So what we want is the priority application should be using the resources, and even though the normal application was already running on the node A in my case, that should be evicted. That should be moved out. That should be moved out. So this will be deployed and this application should come in the pending mode, because that is not my priority. So all this can be done using something known as priority classes, a very interesting concept. So the solution for this problem is the priority classes, right? That is what we will be understanding. So I will be able to do all this thing using priority classes. So every application will be given or will be attached with a priority class. Say the priority class for this application is normal and the priority class for this application is priority or high. So while deploying the application, I will attach a priority class. So I hope you understand the problem. Now let's see the solution. So I have a cluster with me. We will use that. So I clear this drawing and that's my cluster. So I have these machines with me. I do a command kubectl get nodes. I have a 2-node cluster. If I describe you kubectl describe node 1, So node 1 has got around 3 GB RAM, and let me check the node 2. So node 2 has got 6 GB RAM. So let me put it on node 1. Node 1 has got 3 GB RAM. So I'm going to put create 4 replicas. So I use labels and selectors. Let me check kubectl get nodes -- show labels. So this is the default labels. Let me put a label here. I can also do a describe node 1. So these are the default labels. So I'm going to add my own label. So I give the command here kubectl label node, say node 1, give anything, say size, say environment or anything, say environment or say environment is equal to prod. That's it. Like this, right? That's it. This label is done there. Now, next thing I have to do is, so I'm using this because I want all of the applications, all of the pods should be going onto node 1. So I had assigned it a label of environment prod. Now I have to create a priority class, or I have to create actually 2 priority class. One is a normal or a low, or another is high. So you can either get the code from kubernetes.io, or you can go to our GitHub repository, networknuts.github.com /networknuts Kubernetes, and in this we have a high value extra. Now why high value extra? Because these things are generally not a part of the CKA. People don't share these things. So we have a section high value extra where I intend to, or I try to share you as much as things which you might be finding very useful in the production things. So I have to create a priority class. Just copy the code from here. I'm creating 2 priority classes here. So I got this, copy this, and I go back to my machine. Right. I create a folder here, say today, right? Anything. So I go here, like say priority class.yaml, and paste the values here. Now understand this. I'm creating a priority class. Kind is priority class, low priority, value is 100. Now higher the number, higher the priority. So this is a low priority, name can be anything. Global default false means this is not going to be the priority of the application where the priority class is not defined. So you have to explicitly define it. So 2 priority classes are there, low priority with a value of 500 and a high priority with a value of 1000. Perfect. So let me create this. I simply give a command kubectl apply -f priority class. So 2 priority classes are created. So if I check it out, kubectl get priority class, I can see it, high priority, low priority. See, there are these system critical priority classes for the components which the Kubernetes runs. So this is me. So first I intend to run all the applications on node A. Node A has got 3 GB RAM, node 1 in my case. So I have a deployment here, then I create a deployment. This is a low priority deployment. So if I copy this part, copy it, and if I run this, I call it low priority application, low priority app.yaml. I paste it out. So I call it a trivial application. I'm increasing the replicas. My machine has got 3 GB RAM. So the quality of service I'm using is the guaranteed. So 4, 6 are 24. So let me make it 4 replicas. So you have to do this a simple calculation. And in the node selector, I use what was the label? Environment prod, I guess. Let me check. Kubectl describe node 1, and the label is environment prod. Okay, so that is what I will change here. So node selector is environment prod. So every application will be going onto the node 1 environment prod. So guys, please try to understand. We need to do this small calculation here. So this is my application. This application has 4 pods. 1, 2, 3, 4, right? 4 replicas here. 4 pods will be created. Every pod is running in guaranteed quality of service, and every pod is asking for 600 MB of RAM. 600 MB here, 600 MB here, 600 MB here, and 600 MB here. Right. Total comes out to be, total it is going to consume is 2.4 GB RAM. 4, 6 are 24, right? And my machine has got 3 GB RAM. That means after running, my machine has got 3 GB RAM, it will consume 2.4 GB RAM. That means after running these 4 pods, I don't have any resource. Or if I can make it 5 also. Let me make it 5. Okay, but fine. Like it is cool. I don't have any compute left to run any more pods. So, and this I am bounding it, I am forcing it to run on node A. This is going to run on node 1 in my case, node 1. And node 1 has got 3 GB RAM maximum. So let's try this. And see, that is where you define the priority class. Now this is important. This is where you define the priority class specs. Priority class name, no low priority, and the priority class is already defined. So if I run this, every pod should go on the node A. kubectl apply -f low priority. Done. If I check it out, kubectl get deployment running. If I do a get pods running, and if I do a get pods -provide, or everyone should run on node 1, node 1, node 1, node 1, node 1. Wonderful guys. So all the pods are running on node 1. Every pod is running in guaranteed quality of service, has already taken 600 MB of RAM for every pod. So from the total 3 GB is what I have on my machine. We had already consumed 2.4 GB. All is good. The pods are running. Wonderful. Cool. As expected. Now we have another application coming up, which is a high priority application, and that application will also run on the same node. But one application is already running. It has already consumed 2.4 GB and only approximately 600 MB or 500 MB is free here. Right? This is the max free, and this is already used by this application. All the pods are on node 1. So they are using it. They are using this one. So we already have a priority class. Now see what will happen. Because that application will be running in the high priority, the moment I deploy it, because that is a high priority application, these application, the trivial application will evict, and resources will be given to the high priority application. So if I go here, that's the second one, create application. Please feel free to use the code. I just need to change certain things, copy it here. And if I create one more, so this one is, I call it high priority app.yaml, paste it, right? Critical app, that is it. I make it 4 pods again. The only thing I have changed here is priority class high priority. And I have to change the label also, environment prod. That is the label I had given on node 1. Just understand the concepts. Node 1. I'm not running it. I'll show you the priority class first. So if I get the priority classes, and I describe it, see, high priority class has a value of 1000 and low priority class has a value of 500. I told you higher the value, higher the priority. And you can describe it also. kubectl describe priority class and say high priority. It shows you high priority, right? It is not the default one, and this priority class should be used for critical service pods only, right? And if I show you the low priority, the value is 500 and this priority class should be used for non-critical. Fine. Services like this. Perfect. So my new application is using the high priority class. Priority class name high priority. Rest everything is same. See, both are running in guaranteed quality of service. So one thing you should also understand, quality of service has got nothing to do with the priority. They are two separate things. So the moment I run this, guys, let's see the current status of the cluster. The current status of the cluster is get pods -o wide. The trivial application or a low priority application pods are running successfully on node 1. But now I have another application coming up which is also wanting the share on the same machine, node selector. This is also going to be running on the same machine, 4 replicas, but the priority class is high. Now, moment I run this, kubectl get pods, the pods are running of trivial. I give kubectl apply -f high priority. Now see it. The moment I do this and I do a get pods, check it out, guys. These become pending, right? These are getting terminated. Right? And my application, the critical application, will be very soon running here. See, the critical application is running and the trivial application becomes pending. I hope you are able to see it again. See, so I am able to give resources to those applications which are very critical and which needs priority over other application in case there is a crunch of resources. So this is a very important concept. Whenever you want that priority of the resources should be given to mission critical applications. You are encouraged to create your priority classes and assign the priority classes either based on the environments or your clients. It's solely your call. But this is how the priority classes will help you in running mission critical applications in case there is a crunch of resources over other applications. So we can clearly see here that the blue one, the blue application here is pending here. This is pending, and the green application, which was my high priority class, this is running. I hope you have understood the concept. So the crux of the story is create priority classes. You should create priority classes. And then attach like high or low, high priority class, low priority class, and then attach your applications, your critical applications to the high priority classes and normal applications to the low priority classes. So in case there is a resource crunch, the priority will be given to the critical applications running in high priority class. I hope you have understood the concept. Feel free to share about it, how you feel about it. Comment, share, subscribe. Again, it's your call. It's your priority. Thank you very much. I'll see you again. Take care. Godspeed and Jai Hind.